In this video, I want to introduce the method of substitution. Substitution is one of many methods for trying to anti-differentiate or find the indefinite integral of a function. And for each one of these methods, there's an associated rule of differentiation. So let's see this in the broader context. We've already seen the power rule in both the context of differentiation and anti-differentiation. The power rule for differentiation tells us to multiply by the exponent and reduce the exponent by 1, but the power rule for anti-differentiation is sort of the opposite. Instead, we raise the exponent by 1 and we divide by the new exponent. But they're related because they're inverse procedures, right? They're the opposite procedures. Well, then there are the other rules for differentiation. You can ask, is there a method or is there a rule that allows us to do some anti-differentiation corresponding to these rules in differentiation? And the answer is yes. In the case of the product rule, you can do integration by parts. That's something we'll do later. And there's also the chain rule in differentiation, and the corresponding method in anti-differentiation or in integration is integration by substitution. And that's what we're going to focus on right now. So let's remember, what does the chain rule say? The chain rule says the derivative of a composition f composed with u is f prime of u of x times u prime of x. The derivative of the outside function f times the derivative of the inside function u. Now, in the language of anti-differentiation, we reverse the roles of the blue f of u of x and the green. That is, we say the antiderivative of this function, f prime of u of x times u prime of x, is f of u of x. Everything goes backwards when you do anti-differentiation. Okay, so let's take this a little bit further. Suppose, in fact, capital F is the antiderivative, or is an antiderivative, of some little function f. Then I can rewrite this statement above, and I can replace this f prime with a little f. That's because when I say capital F is the antiderivative, what does that mean? That means f prime is equal to f. So instead of writing f prime there, I can write that. So that says the antiderivative of this is this, provided f is an antiderivative of f. So this is the basic fact that leads us to the method of substitution. So let's see how this works, the method of substitution. So here are the 4 steps involved in the method of substitution. So just as in the previous video, we're going to have this. And what we know is that the antiderivative of this, an antiderivative of this, is given by f of u of x, where capital F is now the antiderivative of little f. But let's see this as a process. That's what substitution allows you to do, is make this into a process. So the first thing we want to do is identify the composition. We have to figure out what is the inside function. Just like in differentiation using the chain rule, you have to find out what's the inside function. Here we have to find the inside function. So let's look at an example. Here I have e to the x squared 2x. Well, obviously e to the x squared is a composition, and the inside function I can take to be x squared. That'll be my inside function u. The next step in the method is to change variables. That is, instead of writing x squared, I just want to write u. So what happens is the u gets written as u. Now what's important is that I have a u prime of x dx. So this part, u prime of x dx, corresponds to du. And in fact, that's a definition of du. The definition of du is take the derivative of u prime of x, and then write dx. So these two things have to be the same. So in the example over here, I have u prime. Remember, u is x squared. So u prime, the derivative is 2x. The derivative of x squared is 2x. So I have a u prime dx, and that's replaced with du. If you don't have a u prime here, you can't use substitution. So you got to have a u prime going with the dx so that you can change it into a du. The next step in the method of substitution is to find the antiderivative of little f. So that's what this integral sign is asking for. It's saying find the antiderivatives of little f. So we find that, and in the case of e to the u, the antiderivative e to the u is simply e to the u. So I can replace this with e to the u. But since it's an indefinite integral, I have to add c. Always add your constant. And then the fourth step is to change back into the original variables. Something that some people forget is that you can't just leave it like this with u's. We have to go back to the u of x's. So everywhere you see a u, replace it with u of x. In my example of e to the u plus c, replace the u with x squared. So I have e to the x squared plus c. Now I'm back in my variable x, and I have my final answer. Okay, so that's a brief introduction to method of substitution, and subsequent videos will give you more examples.